subscribe and like the video.
All right. Trapezoids and kites. Trapezoids and kites. Two different kinds of trapezoids that we're going to talk about. So we have two different pictures to do. Before you draw these, I'm going to draw them myself, and I'm going to tell you how you need to make sure and draw these. A trapezoid, by definition, has one set of parallel sides. So when you draw this first trapezoid, make sure that the top and the bottom are parallel to each other, but make sure that the two sides are not the same length. So make one of them longer than the other one, okay? Because that's a regular old trapezoid. All right, so that first one, draw him like that so that the two sides, the left and the right side, are not the same length, okay? An isosceles trapezoid, you're going to make the top and bottom parallel, but you're going to make the two sides exactly the same length, okay? So do that. All right, two different kinds of trapezoids. This is just a regular trapezoid, and this is an isosceles trapezoid, okay?
Does that look right?
So you want, on the top one, you want the two not to be the same length. On the bottom one, you want the two sides to be exactly the same length. That will work, okay? Trapezoid versus isosceles trapezoid, okay? Good? All right, for a regular trapezoid, one thing that I want you guys to note before we move on, a trapezoid and a kite are not parallelograms. These two things, not parallelograms.
Is that going to be on the test?
No. You don't have to necessarily put that, but those two are not parallelograms. So any of the stuff that we put for parallelogram up here does not apply to these two down here, okay? So in a regular old trapezoid, what's true about the sides of a trapezoid?
Two parallel sides.
Just the top and bottom are parallel in this case, right? How do we note on the figure that they're parallel? What's the little marking that we use?
Arrow.
With an arrow. So arrow, arrow. So one set of parallel sides. In this case, it's the top and the bottom, all right? And then there's one other thing that talks about a mid-segment. Here's what a mid-segment is. It's the midpoint of this left side and the midpoint of this right side. If you connect him, it'll kind of split your trapezoid into two pieces, right? And it's equal distant from the top and the bottom, okay? So the mid-segment, they're going to ask you for like the length of a mid-segment, and let's say like this top one is 6 and the bottom one is 10.
8.
He will be exactly 8 units long because, here's the formula. To find the length of the mid-segment, you take the first base, you add it to the second base, and you divide by 2. That's like finding the average of the two, right? Okay? 6 plus 10 is 16 divided by 2 is 8. So B1 plus B2 divided by 2. Okay? I think I wrote the formula this morning as 1/2 of B1 plus B2. So if you like it written like that instead, that's okay as well. Sure. Then just write it as B1 plus B2 divided by 2. Okay? There's that. All right, moving on.
Wait, can you go back up?
Sure.
Okay, thank you.
Okay. Now, an isosceles trapezoid, what's isosceles mean?
Isosceles angles.
Nope. What does isosceles mean?
Oh,
What's like an isosceles triangle?
All sides are equal except spaghetti.
So two sides are equal.
Two sides are equal.
That's why I
Okay?
said all sides are
That's-
equal except for one.
All sides are equal except for one. Right. So isosceles, two congruent sides. I'm going to write that on number 2. Two congruent sides. In this case, it's the left and the right. Okay. Now, the other thing is the top and the bottom are still parallel. So one set of parallel sides. Parallel sides. Okay. One set of parallel sides. All right. Let's talk about the angles now. What do we know about the angles?
they have to all add up
They're
to be
equal
one.
They all add up to be 360, but that's not included in this.
The top ones are the same, and the bottom.
Vertical
ones are the
Top ones are the same, bottom ones are the same measure. Okay? So, I'm going to say we call those base angles. Base angles are congruent. Okay? These two are on the base, and these two are on the base. The top is a base, the bottom is the base angles are exactly the same measure. Okay? And then the last thing has to do with the diagonals. This guy and this guy. Do they split each other exactly into two equal pieces? No. In fact, they intersect. They're not even in the middle of the diagram.
Perpendicular.
Do they make a perpendicular?
No.
No, not necessarily.
Smoke perp.
Okay.
Okay? Are they equal length?
Yes.
Yeah.
Yes, the diagonals are equal length. So diagonals are congruent. The diagonals are exactly equal length. Okay, they don't split each other into two equal pieces. They're exactly equal in length. Good? For the purpose of your homework assignment, listen. Purpose of your homework assignment, we will not be doing just regular old trapezoids. All of the ones on your homework assignment will be isosceles trapezoids. Okay? So, but just take into consideration a trapezoid that is not isosceles doesn't have to have 2 equal sides. It can look like this instead. Okay? Go over to kite. To draw your kite, I had them do this earlier. Draw a horizontal line, about that big. Make like a top triangle, and then make a bottom triangle that's like longer. There's my kite. Okay? If you want to, draw a line down the middle there. That's what a kite looks like.
Actually, I don't see a string.
I haven't flew a kite in so long.
Woo. Oh, wait a second. It goes like this.
What the heck
Like
is
little
that
bows.
thing?
They're like little bows, right?
No, that's not a thing when boys fly kites. Because
Okay,
we're
cool.
not. Gray has the bow.
That's what a kite looks like. Okay?
I don't even own a
All
kite.
right. Now, is a kite a parallelogram?
No.
No, because none of the sides are parallel. It's not even it has one side parallel like a trapezoid. None of the sides are parallel for a kite. Okay? But what is true about the sides?
They're equal. The top
Which
right.
ones are equal?
Top ones are equal.
The
Okay.
offsetting sides.
2 sets of congruent sides, but they are not opposite sides. They are like the top of the sides. They are like the top 2 and the bottom 2. Okay, those guys are congruent, equal length.
Not up.
Okay, not opposite sides.
Up.
All right, what about the angles? Are the angles the same? The opposite ones?
Top two and bottom.
Don't let the opposite.
No,
And-
but the ones,
Yeah.
those ones are these ones at the middle.
Okay. So this angle's the same as that one? Is this guy the same as this guy?
No.
No. So just the left and the right side. So I'm going to say 1 set of congruent sides. And they are just the left and the right side. Unless your kite is like on its side, right? Does that make sense? If you have a kite that looks like this,
My kite is
then it's this angle and this angle. So it's like the sides of the kite, even if the kite's laying on its side, right? Okay. So, last thing, the diagonals. This one here and this one here. What's true about? Do they split each other in half?
No, the perp.
They are perpendicular. They make a 90-degree angle. Okay.
No perp.
So the diagonals
internet
are perpendicular.
Money, bitch.
Okay. Are perpendicular. If you want to write the word perpendicular, you can. The upside down T means perpendicular. So if you want to use symbols, I don't care. Okay. Diagonals are perpendicular. Good.
It's so annoying.
Moving on.
Dad? Question.
What?
When they made that shape, Mother of like God. to fly a kite and it didn't have a name, did they just like name it kite and then that made the shape name the kite, or
If you
was it
can-
already called a kite?
I don't know which one came first, the chicken or the egg. Is that what you're kind of talking about?
Yeah, it's kind of that. Yeah.
Kind of that. Did they name it the shape first, or was it the kite that came from? I don't know.
Is it orange?
I don't know. Good question. Good question.
Why did so if the chicken came first, then
Oh.
why was the egg called the egg?
The color.
I have no idea.
But what if they walked up? And
The
they're
egg
like,
definitely
oh, it's
came from
orange.
the chicken.
Nope.
And then they were like, that's a cool.
All right, you guys have a piece of paper that looks like this. Take this one out. 6-6. Here we go. I'm gonna skip all of these this stuff right here because we've done it on your sheet. So anyway, isosceles. What's an isosceles trapezoid again?
2 sets of parallel sides. Or not parallel, equal
He
sides.
punched me the other
2
day.
sides equal. Shh. 2 sides are congruent in an isosceles trapezoid. Hush. You're getting dangerously close to getting kicked out of here. I don't care. You are getting dangerously close to getting kicked out of your crane. Try me. Try me. All right, 2 sides congruent. Let's go down to the first example. Example 1, this speaker. These are the speakers that you see at like concerts. Why? Here's my question.
They're louder.
Why do they put them in this shape versus putting them as a rectangle? Why don't they make them rectangular
That
shape
makes-
instead of like that?
I've seen them rectangular.
You have?
Okay.
But you've seen them like this though, right? You've seen them trapezoidal shape. Why do they make them this way? What?
In cartoons. when
Why do they make them this shape?
Because they thought it
project
was
more
cool.
sound.
No, they don't project more
They
sound.
go in more
More
directions.
No,
It vibrates.
they all vibrate the same.
They just thought it
The
would
rectangle
look cool
versus a
that way.
trapezoid. Why do they make them this shape?
Space consumed.
No,
Oh,
this
so it
is
doesn't
consuming.
fall over.
Oh, look at that. This one's bottom heavy, right? It's not as easy to topple over as if it was a rectangle, right? So that's why they make them in this shape sometimes. Okay. I don't know why they have this labeled as L. This is actually K. So you can switch that. They labeled that incorrectly. It says the speaker shown as an isosceles trapezoid FJH. Which one's FJH?
J.
The J angle right here. He is 85 degrees. Okay. What else do we know before moving on? Before moving on.
FK is 8 inches.
Nope. Before moving on.
Oh, H is 85.
H is 85 also, right? Okay, 85, 85 degrees. Okay. FK, this little piece right here is 8 inches. What else do we know?
GK is 8.
GK is also 8 from here to here. Okay, so 8 and 8. All right, moving on. It says JG, which is this length from here to here. That is how far?
19.
19. So each bottom is 11 and 11, right? Do you see that?
Yep.
Okay, now, here's my question. This angle up top here and this angle up top here, they are the same, correct? But how much does each one measure?
I know how to figure it out.
How do you figure it out?
So you can add 85 together
19
and then
altogether.
do 360 minus.
Sure, 85 and 85 is 170. Okay, got it. Subtract that from, what'd you say?
360.
360
90.
is 90, 190.
And then you divide it by 2.
Divided by 2, which is
80.
95.
Oh, 95.
Really?
95 degrees.
And then
Okay, do you see that?
Yep.
Now, also, that's not how we did it this morning. This is how we did it this morning, which was faster, right? This trapezoid, all of them add up to be 360, right? If I split it in half, this guy right here, these two have to add up to be
180.
180. These two add up to be 180. So if I know that's 85, I just subtract from 180, right? And that's 95. Okay, let's answer the questions. FGH. What's the measure of FGH?
95.
95 degrees. FGH is this angle right here. Okay? KH is just going from the center down to this
11.
corner. Is 11 inches. There you go. Okay? Good?
Easy peasy.
All right, easy peasy. Let's graph these points. Go.
Oh, you want us to graph them?
Yep.
Hold on.
Grab them on here. -3, 4. Give me a minute.
Craig, please stop humming.
2,
Enough, really?
5.
Still punch me in the back.
I'm giving you so many cancers today.
Just end it all.
I will, Eric.
Don't create any blood in my room.
Don't you have to report him?
I'll do it somewhere else.
Yeah,
Don't you have to
Yeah, I'm
report him?
legally obligated to report you.
yeah.
Okay.
Coach told us about that in practice the other day.
Yeah, because of you.
Definitely wasn't my fault.
All right.
Report him, please.
Okay.
Please. I want to see Craig be like, in like having a talk or something.
Sure.
I'll report him.
All right, did you get him graphed? Did you get him graphed?
Yeah.
Okay. We want to identify whether this is a trapezoid or not. What has to be true if this is a trapezoid?
Yes.
It's,
It's
they have to
really
be
a
parallel. No.
These have to be parallel. Which ones are parallel?
Zombom.
BC and AD.
But that's anyway.
BC and AD. Those are parallel. Okay, so we have to check to see if those are parallel. So we're looking for parallel sides.
Smoke burp.
Okay. So the sides that we are assuming are parallel are BC and AD. How do you check for parallel?
Well,
Slopes. How do you find slope? Formula for slope?
what?
That's slope intercept form.
Hmm.
M is,
Uh,
slope is
X. Y.
rise over run.
Oh.
Y2.
Ooh, X2. X2 minus X1. There you go. Okay. All right, let's do BC. BC are these two guys right here. What's your second Y?
BC.
5 minus 2.
5 minus
3.
3 over
2 minus
2 minus 3. Okay, 5 minus 3 is 2. 2 minus 3 is -1, so the slope is
-2.
-2. Okay, AD. Next,
4 minus
these
1.
guys right here. 4 minus what?
What? 0.
4 minus 0. Then
-3.
-3 plus 1. 4 over -2, which is
-2.
-2. What's that mean?
Yes.
They
Yes,
are-
what? They're
it's a
parallel, so this
trapezoid.
is a trapezoid. It's a trapezoid. Okay, now we have to figure out whether it's isosceles or not. So determine if it's isosceles.
You got
Isosceles question mark. What has to be true if it's isosceles? These two have to be the same length, right? So we've got to do distance. Okay.
Got the phone.
So distance
5.
of sides.
Good for you.
Okay. All right. What are my two sides that I'm looking at the distance of?
A
Which
and
one?
B and D and C.
A, B, D, C.
Trap.
Ooh.
Trap, bunny, a bubble.
A, B, D, C.
Oh, so close.
Square roots, square roots. Okay, here we go. A, B. How far are they in the X? -3 to 2.
5.
5, 4 to 5.
Oh, 1.
1. So 5 squared.
Square root of
1 squared.
26.
The square root of 26. Okay, we're going fast. DC. -1 to 3 is 4. 0 to 3 is 3. So I've got 4 squared,
16 and
3
9
squared. 16 plus 9
is 25.
is 25.
Which is 5.
So what's that mean?
It's
It's not
not.
isosceles.
But is it a trapezoid?
Yes.
So trapezoid, but not
isosceles.
isosceles. Does that make sense? Okay, you got to do the slopes and then you got to do the distances.
I saw.
It is a trapezoid, but it's not isosceles. Now, if you do not come out with two parallel sides, do you have to check to see if it's isosceles or not? Let me say that again so Cray can hear
I
me.
told you, Nicole.
I
That's why
literally-
I'm not here.
Okay, what I say then?
It's not a
said the R
trapezoid if it
word.
doesn't. Wait.
I did not.
It's not a trapezoid if it doesn't have two parallel sides.
Right. So here's my question. If
I
this
heard
does
it
not
correct.
work, if the two sides are not parallel, do you need to check to see whether it's isosceles or not?
No.
No, because it's not a trapezoid in the
You
first
said
place.
at least
Okay.
I'm white.
Moving on.
Whoa.
All right, here's a figure. Next. Here's a figure. Okay, they don't give us x here, and we have to solve for x. We're trying to find this middle line right here that's 15 units. What is that thing called?
Median.
What's that thing called?
I would say that it's gonna be about that.
Oh, you just said it was that silly thingy.
What is that 15? What's it called?
The middle.
The
Mid. We just said it.
midpoint.
The mid. It's on the dang page. Look at it.
Segment.
Mid segment. All right. Okay, I'm going to show you how to do this two different ways. Ready?
Sure.
Okay, to find the mid segment, you add these two together and divide by 2. It's finding the average. So I would take x and add it
12.2.
to 8.2. Divide by 2, it gives me 15, right? Okay, now let's unwind it and let's solve. You add them together, divide by 2. So multiply by 2.
Yes.
X plus 18.2 is
Shut up. You don't even know.
30.
30.
30. Subtract 18.2, and that is
11.8.
11.8.
Oh.
Okay?
That's close.
All right, you ready for the other way?
Yes.
Okay? These are exactly the same distance apart. So, what do you have to add to 15 to get 18.2? 3.2. Now subtract 3.2. 11.8. Okay, so you can do it that way as well. Right? Make sense?
Yeah.
Okay? Good? All right, so that's another way of doing that. That way might have been faster. Just to add the 3.2, subtract the 3.2. Okay, moving on. Now we're talking about kites. 2 more examples. Use properties of kites. It says this thing is a kite, and it wants us to find the measure of angle GFJ. Which one is angle GFJ?
The one that's F.
The F on the side. Okay, what do I know about that angle on the side?
That's pretty good.
It's equal to H.
It's equal to H. I know that this is 128 and this is 72. Okay, how do I find these two?
Staring at the board.
How do I find those two?
You just do.
Well, you see 128, so you gotta be 180 minus 128.
Nope. Nope.
Yeah.
That doesn't work.
Each angles are 90.
No.
Would you add 128
Oh.
plus 72?
Add 128 and 72. Okay, stop there. Hold on. 128 plus 72 is
190.
Um,
200. 200. Okay.
Then
What do they all add up to be?
360.
80.
You got it. 360 minus 200.
Christ, so
160. And then
that's a lie, praise.
Done.
divide by 2. Each one is 80, right? They're both the same. So they both are 80 degrees. 80, 80. They have to add up to be 360. Good? Moving on. These are not hard problems. They're pretty fast. Okay, once you figure out what you're doing.
He didn't write a single thing down.
Okay? Moving on. B, last
I'm a
example.
visual learner.
I bet
All
you
right,
are.
find ZY. Which one is ZY? Shh. Which one's ZY?
Z to Y.
What's ZY?
The
The bottom side right here. It says find that. Okay? We're given this length is 8, this length is 8, 6, 24. Okay, now, did you hear him?
Yep.
A squared plus B squared equals C squared. How do you know we're allowed to do that?
Because it's a right triangle.
This is a right triangle because it's a kite, so that has to be a 90-degree angle. Okay. Which one are we solving for? A, B, or C?
C.
We're solving for C. So we're looking at this triangle right here, and we're solving for C. Okay. What do you want A to be?
8.
8.
Yeah.
Great.
24 is B, and we're looking for C. 8 squared is
64.
64. 24 squared is
576.
576. You betcha. Equals C squared. Okay.
Hold on.
64 and 576. Go.
640.
640.
I already did it.
Okay. Take the square root of 640, and C is
25.29.
25.3. Let's go with that. Okay. Let's check to see if that looks appropriate. This is 25.3?
I
Okay.
would say so.
Now, hold on. What could C not have been? Like, if I got
Less
this as an
than
answer.
those.
It can't be
No.
less than 24, and it can't be less than 8, right?
Yeah.
Because
Of what we
that has
did
to be the
last
longest side, right?
chapter.
Yeah, kind of what we did the last chapter. It can't be, it has to be the longest side, right? So it has to be bigger than 24. You know that for sure, right? You have some like that on your homework assignment, right? That can help you kind of figure out what's appropriate and what's not. Okay, good? I'm going to give you your homework assignment. Do all. Did you hear what I just said?
I did.
Do all, both sides. They're not hard. They're not hard. Both sides, skills practice, do all. Okay? Goodbye.